Hi everyone, welcome to our project for the second scientific conference for students 2021 with topic Effects of fluoroquinolone exposure on the growth of Staphylococcus aureus ATCC 29213 under the supervision of Associate Professor Nghiên. Staphylococcus aureus, or SA, is gram-positive bacteria which is non-model, non-spore-forming, facultative, anaerobic, and spherical shape. This bacterium is a common extracellular pathogen with ability to cause a wide range of infections, such as skin infections, pneumonia, osteomyelitis, urinary tract infection. The treatment for SA infection usually involves antibiotics, especially fluoroquinolone. But the major problem is that SA develops its resistance when being exposed serially in an antibiotic. Besides, antibiotic resistance ability has been reported to either reduce or increase the bacterial growth depending on specific culture medium. In this study, we investigated the alternation in the growth of SA-ATCC 29213 after serial exposure to subminimal inhibitory concentration values of FQs including ciprofloxacin, ofloxacin, and levofloxacin in the antibiotic-free media. Briefly, 7 SA strains including SA-ATCC 29213, initial SA, and its in vitro-induced FQ-resistant strains generated via serial FQ exposure were cultured at 37 degrees centigrade, 120 rpm in either NB, LB, and MHB. Plate counting was applied using corresponding media to check for bacterial growth. The data were collected to compare the growth rate between initial aureus and its in vitro-induced FQ-resistant strains. According to the growth curve of 7 SA strains in the 3 different media, in most cases, in vitro-induced FQ-resistant strains enter stationary phase faster than initial strain through the maximum plateau population size, which each strain reached varied. Besides, under the effects of FQ's exposure, most of an in vitro FQ-induced resistance SA exhibited significant difference in growth rate compared to initial one. Furthermore, almost all in vitro-induced FQ-resistant strains showed significantly lesser growth rate in LB and MHB medium, however higher growth rate in NB compared to the initial SA. Therefore, FQ-resistant mechanisms are associated with a fitness cost that either reduces or increases the growth of SE depending on a specific medium. In conclusion, these results interestingly suggested that the adaptive FQ resistance mechanisms are associated with a change in the bacteria metabolism, which somehow resulted in a decrease of growth in a nutrient-rich medium, but an increase in a nutrient-less one.